Okay, so I'm recording now. I'm gonna open the editor just to a new sketch, so I have that open to demo. Whoops. Oops. I keep putting characters in here by accident. Okay. So just going to talk about P5 a little bit more. So we've already used P5 starting last week. We made some cool drawings, and we kind of just like really dove into the deep end and started using it without really explaining what's going on very much. So now that we've used it and we kind of see what it does a little bit, we're going to go back and look a little bit more into the specifics of what it is. So a couple links here just on the background of P5. This is the P5 website. We did actually see this when we looked at the reference last week, but this is the homepage of the website. And there's a lot of useful things here. There are some, it has a link to the editor. It has a download link. It has some tutorials and reference pages. There's also some libraries that you can add on to the basic functionality of P5. There's a bunch of tutorials here that kind of review stuff. There's a lot of examples. We actually looked at how you can find the examples from within the editor, but you can see the examples here as well. So you can kind of see different stuff that you can do with the P5 library. There's also, a link to contribute on the GitHub. This is something that probably won't make that much sense, but there's also a community section with lots of information there. There's a showcase website where you can see interesting projects made in P5 over the years. So there's a lot of cool stuff, to check out there. We'll probably look at more examples from there in future classes. So that's a P5 website. And P5 comes out of, it's sort of inspired by and kind of comes out of a community that's related to another programming language called processing, which is right here. Processing was first created in 2001. And the idea behind processing was basically to make a more approachable programming language specifically for artists and designers. You could make things with code without having to like do a lot of crazy, sort of like basic stuff of managing computer memory and compiling code and doing all these other things that were very challenging back then. So it's really meant to kind of get off the ground and really focus on programming concepts with an idea that it'll be used by artists and designers. And eventually it also became very popular with educators. So that's a big part of it as well. So that's kind of where it comes from. And you can see there's like different versions of this now. Processing is based in Java, which is a classical programming language. So that's kind of where it comes from, and that's why it exists. And it's become very, very popular over the last 20 years. So P5 borrows a lot of stuff from processing. There's a few things in the two languages that are not 100% compatible, but most of the terminology it uses is the same. And most of the functions are the same. So I think I mentioned this last week, but both programs think of as our code as a sketch. So we use our code to sketch out an idea. So we think about it like we're doing a drawing or a painting or a design or something like that. But of course, we're using code, and that allows us to do lots of other things that involve interaction and multimedia and stuff like that. So we're using the P5 web editor. There's a link right here, but most of you guys have already been on there. And one thing I want us to look at that we didn't look at last week is how it's set up. So basically, whenever you create a new P5 project, it's going to have these three basic files right off the bat. It's just going to make them for you. And where you can see that is if we go back over to the P5 editor, there's this little arrow next to where it says sketch.js. And if we click on that, we can actually see the file system, the files that it creates for this website. And these files are probably going to be familiar to most of you guys who have taken MMP 100 or another multimedia class. We have index.html. As you guys probably know, this is the main page of every website. And it's a very, very simple page. It barely has anything in it, but we can go over what's in it. So we have our normal HTML declaration. We have our HTML language here, And then in our head section, we have a bunch of stuff. And the main things that this sets up for us, which is kind of nice that we don't have to do it on our own, this is a link to the P5 code. And so it automatically just builds that into our website. And if we click on this, if we go take a look at what this actually looks like, it's just like a gigantic, big thing of code that kind of makes it easier to draw circles and create colors and stuff like that. So this gets loaded into our website by default. There's also a link to the sound library for P5. So we're not going to use the sound library until a little bit later in the semester. But that gives you access to playing audio files and synthesizing audio and doing other things that are not part of the basic P5 library. There's other stuff that you can add on top of it, but those are the two defaults that you get. There's a link to the style sheet, which barely has any rules in it. We'll look at that in a second, but it's there if you want to add more, and we will talk about that in a future class. And we have our meta char set. I keep hitting random buttons. I should use my mouse instead of the trackpad. Okay. Then our body section of our website is like barely has anything in it. There's this like main section that doesn't have anything in it. You could put stuff in there if you want. And a script to our link to our sketch.js. So that imports our code where we write our own code in that sketch.js file into the website. So that's our index.html. Our style.css literally has this is all the styles that we have, because all we have in this project is, did I just add a bunch of, okay. Anyway, all it's doing is taking off the default margin from the body, so it doesn't like float in the middle of the page, and then it sets the canvas display to black. That's really all it's doing. So most of what we're working on is this sketch.js. This is our JavaScript code where we're actually drawing our sketch. You can add files here, so if I click on this plus, you can do all the stuff that you would do in a website, like add more HTML files, add more CSS files, add images, add other media files. You can do all that stuff here. You can make folders and stuff like that. But the majority of the time, we're never even going to go in here. We're just going to use the default setup and work from here. But it is basically just a small website. So when you create a website, you could download those files, you could publish them on a website, and it would just look like a pretty simple website. There is a preview mode. So if I open one of my old sketches, and I go to share and I go to full screen, this used to just be the sketch by itself, but it's kind of annoying. They added this little like banner here so that it's created by P5. I find that a little annoying. I don't know why they did that, but that's what it looks like. But anyway, it has like a link back to the code. But it used to just like literally just be the canvas, and that's basically what it is. Of course, we can add other stuff into the website if we want to, and we will actually do that in a few weeks actually. Anyway, that's how it gets set up. So when I hit file and I hit new, it creates this new sketch for me, and it automatically makes all three of these files for me, and it puts me in sketch.js where I can start to write my code. So it really like streamlines that whole process, so I don't have to think about all that stuff. I can just start writing some code. So that's very convenient. So all of this works because of the HTML5 canvas. And the canvas, without going into too much detail, is basically like a graphics rendering node in HTML. So before the canvas existed, HTML was just text and images and videos and stuff like that. And you couldn't do like interactive graphics. So people used to use this thing called Flash. You guys may have played Flash games at some point in your life. Flash was the only way to do that type of graphics up until the canvas existed. So like for me, my first job that I had when I moved to New York was I made Flash games at like a small video game company. That was literally the year that the iPhone came out, and then Flash got X'd out by the iPhone, so everybody switched over to HTML5 canvas and JavaScript stuff, which is great. I love JavaScript. So Canvas started around 2011, so it is actually kind of new compared to a lot of the technologies we use, but it's been around for long enough that we know how to use it and we can do lots of cool stuff with it. We can use just vanilla JavaScript, which is JavaScript without P5. With the canvas, you can do all the same stuff. P5 basically takes things that would take a long time to write in vanilla JavaScript and makes it into rect and circle and square. So it's very nice for that reason. So yeah, I talked about this a little bit last week, but the way the P5 canvas is set up and the HTML5 canvas in general is set up is using X, Y's 0, 0 origin is at the top left hand of the canvas. So this is different than what you learn in math, the Cartesian coordinate system where 0, 0 is in the middle. You can change it. You can actually make it oriented this way if you want to, but the default is what we see on the right. So this is confusing at first because Y goes down. So the Y value, as it gets larger, you're going down the page. That's the one thing that is kind of confusing about this, but you'll get used to it. Okay, so we're gonna make a program. We kind of already did this part. So let's talk about functions. Okay, so when we start P5, there are two main functions. I very briefly talked about this last time. I'm gonna talk a little bit more about what this does now. So I'll show you an example of how these two functions are different. So setup runs once, and it just sets things up. So the main thing that we need to do is create this canvas. The canvas doesn't exist on its own. We have to make one. So that's what create canvas does, and we say how big we want it to be. We kind of already talked about that. We can draw it in setup, but one thing you'll notice, let's say I want to draw a circle here. We don't see the circle, right? So that's because draw exists. And as soon as we run our program, draw starts drawing graphics. So that's why we see that background. But if I take draw out for a second, we do see the circle. Okay, so you can actually make a drawing in setup. You can do all the different stuff in P5 that you would do otherwise. But mostly what we want to do with setup is just if we want to do one thing. So if you're just making a design that doesn't change and doesn't do anything, you could just do the whole thing in setup and just run it, and there's your design. That's fine. The reason that we use draw is because we want to eventually do animation and interaction, things that change over time, that dynamic aspect of programming that I kind of touched on last week. So I'll show you in draw, if we have our background. Our background is going to cover up that circle. That's why we don't see it. If we take out that background, we still see the circle. So the background is actually covering up what was drawn previously. And this is pretty much how all computer graphics rendering works. So if you're playing a video game, you've probably heard video games running at 60 frames per second or something like that. Basically what that means is that as you're playing the game, the computer is collecting information from your mouse and your keyboard and what you're trying to do, and it's calculating all this crazy stuff and saying, okay, there's like a car over here and there's some buildings over here and the camera is facing this way, and then it's painting all that stuff onto the screen, and then 60 times per second, or sometimes more, it has to do all of those calculations all over again. So it's doing a lot of crazy stuff. And that allows us to create motion. That allows us to create animation. So in MMP 100, you learned about animation and the persistence of motion. The idea that if we move the circle or shape or whatever fast enough that we stop seeing it as individual images and we see it as continuous motion. That's what creates animation and film and all these other things. It's the exact same thing on here. Our computer is painting the stuff that we're asking it to paint, and it's doing it really, really fast. And so that's why we can do something like this. So if I draw the background, and we're going to learn this in a couple weeks, I'm going to draw a circle at mouse X, mouse Y, and now you can see the circle's moving around, right? So the circle's moving according to where my mouse is going. And it looks totally normal, right? It looks like the circle just moves. But if I take out this background, you can see what's really happening is we're painting the circle over and over and over again. But because we're drawing that background, it covers up all the previous circles. So now, instead of seeing all this whole long history of circles, what we see is one circle that's moving around. So that's why that's how draw works basically. And draw is going to default to 60 frames per second. It's going to be redrawing your design 60 times per second, but we can actually change that. So if I set something like frame rate, if I set this to like 2 frames per second, you can actually see, how often it's updating. Okay, so it's only going 2 frames per second. So we see my mouse is moved and the circle is just keeping up. And if we up that, if we do 5 frames per second, now we can still see that it's like, you know, different images, but it's starting to look a little bit more like motion. When we start to get up to around 12 frames per second, now we can still see that there's a little bit of a lag, you know, but it's starting to look more like motion. So but somewhere between 12 and 24 is when we stop seeing individual frames and we start seeing motion. So if we go up to 24, and it depends on a lot of various factors, but when we get up to 24, now we see smooth motion. We don't see individual images anymore. So that's like the standard for most animated films, for 2D animated films, is 24 frames per second. If we go, you know, somewhere in the middle, well, we already saw 12, so you guys get the idea. And then the default is 60. So 60 is pretty fast, but some more advanced computers, like if you have a VR headset, running at 60 frames per second, it's going to make you throw up because of the motion sickness. So VR, because you're only looking at that image, VR is trying to go 120 frames per second, which if you really think about that is like kind of insane that the VR thing that's like this big and you're in like a room and it's calculating all of this stuff and it's doing it 120 times per second. Like, it's pretty wild, right? That's what it's trying to do. And we're only getting higher and higher and higher. Like, eventually, you know, if you have what's the Apple Pro that just came out? You guys have seen that, right? Yeah. I think that's doing like 144 or something like that, maybe higher. It also has like a crazy number of pixel density. It's just like, it's totally wild. But anyway, that's what that's doing. Okay, so now we understand the difference between setup and draw. Setup does one thing. It sets stuff up. It can draw. It can do other things, and we will use it for lots of stuff in the future. But draw is going to be drawn over and over and over and over again. And these functions are a little bit different than normal functions because P5 knows that they exist. So for example, if I call this like setup 3 or something like that, notice that it changed, so it just went back to those defaults. So P5 knows that I'm going to have a setup and a draw function or like a mouse press function, and it's going to look for those and it's going to do whatever I put in those. But if I say like draw, you know, blah, 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 it's not going to do that because it's not looking for that. And that's a little bit different. Usually we create a function and then we say when we want the function to run. We'll do that later in the semester, but P5 sort of says, okay, we know that we need to set stuff up. We know that we need to draw stuff. So just use those things and then we'll handle running it for you. So that's set up in draw, and those are our functions. But a function generally is just a series of commands. So there's a couple of different ways that I like to think about it. Function can be like a recipe. So if you're going to write a recipe for a peanut butter and jelly sandwich, you would say like, you know, get some bread, get some peanut butter, get some jelly, put the peanut butter on, put the jelly on, put it together, cut it in half, whatever. You'd have like a series of instructions for what you want to do, but you could modify those instructions. Maybe your jelly has different flavors, maybe you skip the peanut butter, maybe you cut diagonal versus cutting in the middle, horizontal or whatever. So a function is like that. It's like a series of instructions that you want the computer to do, but there might be changes depending on various things. And so usually, what I was mentioning before, usually when we write a function, this is how we do it. We say function, and this tells JavaScript that we want to create this series of instructions, and then we give it a name. As I mentioned, they have to have their own name, and the names can't be the same. So I don't want to call this draw, but let's say I had a sandwich function. I'll just call this sandwich. So then you have these parentheses, and we see parentheses all over the place, so that makes sense. And we'll talk about what they do in a second. You have these parentheses at the end, and then you have these curly brackets. And so you probably don't use curly brackets a lot in your day-to-day life, but in programming, you use curly brackets a lot. This is what defines the beginning and the end of the recipe. So we have the name of the recipe, and we say it starts here, and then it ends here. And we're going to have lots of different recipes that sometimes they work together. Sometimes one recipe has like a whole other recipe inside of it, right? Like if you're making, you know, stir fry and there's a sauce recipe, there's like a whole other recipe inside the one recipe. So this says this is where we start, this says this is where we end, and then anything we want to do, our sandwich to do, we put in here. So let's say we want our sandwich to draw a circle at 100, 100, 100. That's the first instruction. So make a circle, then make a rectangle. And we'll do the same thing. So let's pretend our circle is our jelly and our rectangle is our peanut butter, and that's how we're going to make a sandwich. One thing that's a little bit different is you notice that we don't see our sandwich anywhere. And so normally when you create a function, you have to call the function. And so that's what's a little bit weird about P5 is that the draw function, we're creating that function, but we don't actually call it, versus background and ellipse. P5 created those functions for us, and we are calling them by writing them with our little numbers. So if I want to call my sandwich function inside my draw function, I just say sandwich here. And now you see my sandwich function. So we'll talk about that more. That's the basic idea. And I can make as many of these different functions as I want. Anyway, we'll talk about this a little bit more in a couple weeks, but that's the basic idea. So this, when we write a function, this is called a function declaration, which basically is just saying this is the function I want and what it does. And when I call the function or run the function, this is called call, invoke, run. There's a bunch of different terms for it, but it basically just says do what the function says to do. So that's kind of how functions work. Functions have arguments, and so that's what these numbers in between the parentheses are. And basically what the arguments are the ingredients. So you might have a sandwich with, let's say our sandwich has, let's say instead of jelly, we have a color. So we're going to say fill, and it's going to be whatever this color is. So let's just call this jelly color. And so our argument would go here. We'd say jelly color here. And now if I run this, there's no jelly color, so I'm getting this error. It's like, this doesn't work. So now I need a jelly color. So if my jelly color is red, now I have a red sandwich. If my jelly color is blue, now I have a blue sandwich. So that's what an argument is. It's like the ingredients. It goes into the function and it changes the outcome. So if you have a peanut butter and jelly sandwich and you have grape jelly, you end up with a grape jelly, peanut butter and jelly sandwich. And so like our ellipse function, we looked at this last week, but it has 3 arguments. It has the x position, the y position, and the size. And so in this particular sketch, the x position is where my mouse is, and so is the y position, so that changes. But the size is 100, so that's why the size of the circle doesn't change. So if I change this argument to 200, now it's bigger. So our arguments have like a particular order, and then they have a particular thing that they do. And eventually, as you use the functions, you'll sort of remember what these things are. But that's what the reference is for, is figuring out what they are. So when you go to the reference and you're like, what does, how do you do a square? It's going to show you, parameters is another word for arguments. So arguments or parameters means the same thing. It's just the ingredients that we put into the function. So it shows us the order, x, y, and s, and then it explains what they're used for. So if you don't know what order to put the numbers in, you can look it up in the reference. Okay. Okay, we talked about this last week, but with the create canvas, this makes the HTML5 canvas. It takes these 2 numbers for the size. So 400 is the width, 400 is the height. If I change this to 600, we get a wider canvas. It's the basic idea. And I also think I mentioned that camel case, if we have 2 words in our function, we can't use spaces in code because a space means we're doing a new thing. So we use capital letters to signify this is like, the second word of this function name. So that's why you see, for anything that's just 1 word, like sandwich, it's just all lowercase. For anything that's 2 words, like create canvas, we use the second word or third word, fourth word is going to be capitalized. Yeah.
Is there a way to change the color of the shapes in the sandwich individually?
Yeah, I would have to have two arguments. So I'd have to have a jelly color and a, let's just call it butter. I'll just call it jelly and butter. I don't know. And so then I would just put like red for the butter color. Sorry, I'm trying to use the same quotation marks. And then I would just put a fill in here and put butter here. Oh, but I changed the name of this. So then I would get that. But don't worry about the arguments too much. I'm just explaining what they are, but we're not going to use them a lot for at least a couple weeks. Okay, so we create our canvas, and now we can draw our sketch. And we played around with the values last week, so let's skip over that for now. Talked about the reference. Okay, let's talk about our shapes. So this is the last thing I'm going to do, and then I'll give you guys some time to work. I'm going to go over the shapes again. I kind of went over the shapes before, but let's go over our shapes again. So let's go into draw, and let's do some shapes. And I'm just going to cover the basic shapes. So let's go back to the reference page and go to shape. And we'll just go through all our 2D primitives. But I'm not going to go in alphabetical order because that's going to be confusing. I'm going to go in order of complexity. So the least complex shape is the point. And this is literally just a point. It just has two numbers. So if I want a point, I'm just going to write point. And I'm going to say, let's put it at 200x and 100y. And I can see it. I don't know if you guys can see it on the projector. It's tiny. So we can't really see the point because it's just a point. But if we want, I think we can increase the stroke weight. And now, oh, maybe I can't see the point. Maybe that's just dust. Do I need to move the point over? Oh, there's the point. That was just dust on my screen. Okay, let's see what the point looks like. Yeah, it still looks like dust, and I still think you guys can see it. So the point without, at the default stroke weight, which is 1 pixel, is literally just 1 pixel on the screen. So you can barely see it. But if we turn the stroke weight up, then we get this weird sort of circle. But then we might as well draw a circle, right? So the point is not really that useful, but it exists. So that's the least complex shape, is a point. And it's just an x value and a y value. So if I increase the x value, it moves over. If I increase the y value, it moves down. If I lower the y value, it moves up. It's a point. It's very straightforward. The point is kind of in between our two concepts of shapes. So remember, we talked about this a little bit last time. We have two types of shapes. We have shapes that have a center or origin point and a size. And then we have shapes that are just a series of points that are connected. So our next most complex shape, depending on which point of view, and let's just go through the point-based shapes. So the next most complex is a line. So a line takes 2 points and it connects them together. So let's connect a couple points. I'll do like 300x, 300y, and I'll go to 400x, 400y. Okay, so we've got our line down there. And so the line doesn't have a size, right? It has these two different points, and no matter where those points are, the line will connect them. So if I make the y values the same, then I just get a straight horizontal line. If I make the x values the same, now I've got a point, because the 2 points are on top of each other. Okay, so I have to move somewhere to make a line exist. If my y values are the same, I get a horizontal line. If my x values are the same, I get a vertical line, because it doesn't move on x, it'll just move on y. So yeah, a line, and then the line also obviously is affected by the stroke weight. If I took out this, it would just be really skinny. We can still see it though, because it does take up more space. But also, if we said no stroke, which takes off the stroke, then it just doesn't exist, because it's not drawing anything. So our line and our point need to have a stroke to be visible. Okay, so then we get to our triangle, which is the scary three points. And the reason, we talked about this last time, the reason the triangle is scary is because to move it, you have to move every single point the same amount. So let's draw a little triangle. And with our triangle, we had 3 sets of XY values. The other thing that's a little tricky when you're starting to draw these shapes is that you have to go XY, XY, XY. And that can be kind of confusing because we have to think about these different spaces. Then we have to order our points. So last time I showed you guys a trick where I draw a bunch of circles and then I turn those into my points. That's one way to do it. Another way to do it is just to kind of figure things out. You could design your own triangle function, which does it a different way, which is something that might be useful. But let's just draw a quick triangle. I'll do, let's see. Let's start at 300x and 100y. So that's going to be our first point, and then we have to move, let's move down. So let's do 300, 100, but then let's move down. So that means the y goes down. And then let's move over. So we'll go 400, 200. Okay, so we've got a triangle. So again, if I want to move this triangle over, I have to move every single point. So let's say I want to move the triangle over by 50. If I move 1 point over by 50, it just moves 1 point. So I'd have to go over to the next x and move that one and go over here and move that one. So the triangle is a little bit tricky. You just need those 3 points, and yeah, you'll figure that out. So then we go up even more in complexity. So after triangle, we go to quad. And then after quad, we leave our 2D primitive zone and we go somewhere else, which is either the vertex begin shape or curves, where we can make more complex shapes. But we're going to skip that for today. We're just going to stick with our 2D primitives. So our quad is 4 points. I think we saw some quads in our homework, which is great. And so the quad is just the same thing as a triangle. We just add another point. So it just adds a little bit of complexity. So let's add a quad. Let's move down a little bit. Let's keep our x low and move our y up. So we'll do like y is 300. And if I want to just draw a square, I would just move over on x first. So from 100 to 200, stay at 300, that's at the top. Then let's stay at 200x and move down on y. And then move back to 100x and stick on 400y. There we've got a quad, but it's really just a square. But the difference with the quad is I can start to vary this. So I can move 150 over and move 350 over. Oh wait, that was the wrong 350. Yeah, this is where it starts to get confusing because I've got 4 different numbers and I have to remember which one does which. Okay, I want to move my second x over. That's this one. The order also kind of matters here because if we have them out of order, it'll like twist it into a bow tie. That could be kind of cool, but if you want it to look like a square shape, you need to get the right order. So the reason this works with this one is because I started here, so 150x, and then moved here 250x. Then I went down on y, and then over back on x, and then back up on y. Or actually, I stopped right here. But with the quad, you kind of have to be aware of the order. Okay, so those are our point-based shapes. That means that we are only describing points where we want the shape to be. So the other type of basic shapes that we have are origin with size-based shapes. Okay, so we've already looked at these, and these are the ones we tend to use a lot for making basic stuff. And what we have, they used to actually only have ellipse and rect, because ellipse and rect are technically, or a square is technically just a rect with the same width and height, and a circle is really just an ellipse with the same width and height. But I think people got confused because ellipse and rect don't sound like shapes. They sound like weird things that don't exist. Square and circle sound like normal shapes that we talk about, so they added those in. But they honestly are the same. If I do a circle, or I already have a circle that I'm playing around with up here, But if I do a circle, and I do, let's say 200, 150, that's this like red circle right here. I'll move it over a little bit more. So if I do that circle, that's a circle. If I do an ellipse, that's exactly the same thing. It's gonna look exactly the same. So with the ellipse, you actually don't have to have a different width and height, but you can. So if I add like 20, now I have this like little like basketball thing. So the ellipse, the second or the fourth number rather, the second size number is the height. So I can make the height smaller or bigger. If I make this larger, oops, then I'll have like a nice oval shape, like a little mirror. So yeah, ellipse is just a circle, but the width and height can be different values. Same thing with square. So if I have a square, let's stay here but move down. Okay, so if I have a square, there's my little square down there. 300 is the X, so I move over 300 pixels. 200 is the Y, I go down 200 pixels. 50 is the size, so that's the width and the height. If I want to do a rect, so I'll make a little rect. I'll move over this time, so I'll say 350, or let's say 360, or no, let's do 375. So we'll move over to the right, and I'll move down a little bit. I'll do 225, and I'll do 50, and I'll do longer. So now I have a rectangle. So a rectangle, same thing. It's just like a square, but it can have a higher height or wider width than the square. Okay. The rectangle also, a lot of these shapes have optional arguments. So if you look at the reference for, let's look at rectangle. When you look at this, you're going to see the basic syntax, so x, y, width, and height. You can see that the height is optional. But then there's these other things that are in brackets. So if it's in brackets, that means it's optional. And what these things actually mean, so what is TL? TL is the optional radius of the top left corner. So we can actually round our rectangles, which is kind of nice. And then, this is for 3D, so ignore this part. Okay, so let's go. So if I take my rectangle and I add like 10 at the end, I get this nice rounded corner. And that applies to all of them by default, but if I keep adding numbers, like if I had 20, now we start to move around and add more roundedness to each one. And there's like a limit to this, obviously, so I think I hit the limit at 30, depending on the size of the rectangle. But if we make it a little bit wider, now you can see, okay, yeah, you can see it's like 10 pixels of roundedness, 20 pixels of roundedness, 30 pixels of roundedness, 50 pixels of roundedness. So that's an easy way to add a little bit of detail to the rectangle using these extra variables. And almost all of the shapes have some like optional parameters. So with this one, it's just the optional one is height. That's not that interesting. Let's see if there's others. Actually, the next one we're going to cover has a lot of parameters. Okay, so we have one more to do, which is also in our origin and size-based shapes. This is the arc. The arc is a little more complex. Some of you guys did use the arc in your homework, which is great. The arc is just a circle, but it's cut out a certain amount. So you can make shapes like a pie or this thing, whatever you would call that, like a circle that's sliced off. This is like a little pie or a Pac-Man. You can make a little pie slice, and then you can also just make the stroke of the arc as well. So this is useful if you're doing like a pie chart or you're doing eyes or ears or something like that. So this has the same values as a circle, x, y, width, and height. But then we have a beginning or start and end stop of our circle of our arc detail. And this uses radians, which is calculated using pi, which is the geometric constant that tells us how to calculate the angle of a circle. And then there's a two optional mode is the style it draws. So it can either draw straight across or it can cut in like that. And then detail, what is detail? That's also 3D, so ignore that. So let's draw an arc, and then that'll be all of our shapes. Okay, so when we want to do an arc, we say arc, and let's do an arc over here. So I'll do 500 and 100. And then I'll do, let's just do 200 by 200. Or no, that's going to be too big. Let's do 100 by 100. Okay, so we don't see our arc, and we might have an error. Yeah, so it says expecting 6 arguments, but we only got 4. Okay, so to calculate our arc, what we're going to do, basically, when we have a circle, let me hide, or I'll just leave this circle here. Okay, so when we have a circle, the way that P5 does it, there's different ways to do it, but the way that P5 does it is the angle of our circle, this is 0, and pi is used to describe the angle of the circle. 1 pi, or 1 rotation on pi, gets us to here, so it's half the circle. So if we want, like, this half of the circle, we start at 0, and we just go to pi. And we can actually just write pi, pi, P5 knows what that is. If we want to go all the way around, we go 0 to 2 times pi, or 2 pi. And then obviously there's different intervals in between. It's kind of hard to calculate, so I usually just divide. So I say like pi over 2, pi over 8, pi over 16, whatever. But you can also say like, 1 point something and see where you end up if you're going to do that. But yeah, so let's draw that. So we can say we want to start our circle at 0 and we want to go to pi, which is just capital Pi. And you see we get half a circle. And it has our fill and our stroke. And then if we change the mode here, we actually won't really notice anything at its current setting. So let's skip that for now. So then if I say pi times 2, we get the full circle. And if I want to go somewhere in between that, like pi times, we could do like 1.5. That'll give us this, 3/4 of a circle. So that's basically how the arc works. And then if we add on this optional thing, there's a chord, which means that it just it fills across the 2 points. The other ones are pi. Pi, I think, just makes, whoops. Okay, I did something wrong. Oh, no, this doesn't go in quotation marks. This is actually a variable, but it's something that P5 creates. Okay, so pi fills in the stroke, and then open doesn't fill in the stroke. Did I get an error? Oh, chord, okay. Oh, if I leave it empty, then it does that. So there's actually 4 options. Empty is that it cuts out the pi, but it doesn't add the stroke. Pi still cuts it out, but adds a stroke. And chord does the chord, but adds a stroke. And open draws across, but doesn't do the stroke. Okay, you might not really, that might be more detailed than is really necessary. So that's how you do the arc. So the arc is a little more tricky, but obviously you can get some more interesting shapes with that. One of the things that often comes up is how can I rotate the shapes? Can I do different stuff like that? And the answer is you can, but it's a little bit more tricky. And we are going to cover that in a couple weeks. And you can look it up on the P5 reference it or Google it or figure it out on your own if you really want to do that. But for now, we're just focused on doing shapes. Okay, I'm gonna pause here because I've been going for a little while. You guys can work on the self-portrait, just start adding some shapes. We'll take our normal break from 3:40 to 4. And so if you guys need to, leave and do whatever, you can do that. Obviously, you don't have to wait for the break to do that if you want to use a bathroom and stuff like that. But at 4, I'll do a shorter lesson on color, and then we'll have a lot more time at the end of class to continue working on the self-portrait project. So for now, you can make a new sketch, start brainstorming what you want to do for your self-portrait, start playing with the shapes, and then if you have questions, if you want me to take a look at anything you're working on, let me know and I'll come over and take a look. Any general questions that I can go over? Yeah.
You see you have like a guide that you use, the X, Y.
Yeah.
What is it? Or just what is it?
So-
Like you see you teach last class that wasn't here.
Oh, yeah.
A way of like how to get easier the position of X and Y in drawing.
I'm not sure I understand.
No, right? Maybe I'm just wondering.
Like,
Like I thought you say you had a way.
yeah.
A personal way of like calculating X and Y position when you're like drawing.
Oh, I kind of just guess.
Okay.
But actually, what you could do, somebody did this last week, which was smart. If you do this, function mouse pressed, you can say console.log mouse X, mouse Y. And then if you click somewhere, it'll print out the X and Y values down here. So that actually could be really useful. Like if you're trying to figure out where to put something, you could put that in there. Okay, I'm gonna save this even though it's kind of a mess for you guys to look at, and I'll put it in the class collection. Actually, just as a reminder, so if you are looking for one of the class examples, I usually put them in the description of the video, but you can also go up on the class page to links and go to class examples, and you'll see the projects that I've been doing as demos in class. I didn't name this one yet, so it says Clear Flame, but that's the one that I've been working on. I'll just call this Shapes Review. So yeah.